Hello once again, you're welcome to our channel. Today we shall be discussing on how to calculate the vertical deflection on a cantilever beam. Once again, how to calculate the vertical deflection on the cantilever beam subjected to a moment of 30 kilonewton per meter with the length of the cantilever beam of 2.0 meter. Let the stiffness ER equals 8 times 10 to the power 5 Newton per meter square. Now, first of all, for us to calculate the vertical deflection on the beam here downward, we need to use a method called a virtual load case. How do we use the virtual load case? First of all, we have a cut in the beam section at the middle. By cutting it in the middle, we have the vertical force of unit load of 1 as a virtual load case, and we have the cut moment, which is virtual moment M, and we have the shear force subjected. Now the length of the cut cantilever becomes 2 minus x. Now the summation of the moment from the section cut x becomes negative virtual moment plus 1 times 2 minus x. So therefore, our virtual moment gives us 2 minus s kilonewton. Fine. Now, in order for us to calculate the vertical moment, the vertical deflection of the beam, we need to calculate the real load case too. So therefore, we now replace the real moment, which is 30 kilonewton, acting at the tip of the cantilever. So therefore, we cut the cantilever beam into 2 once again. So therefore, we have our cut here, which gives us the moment acting clockwise, which is 13 kilonewton. We have another moment acting on the cut edge with the shear force and the X cut acting towards the surface of the cut. So therefore, the summation of the moment acting from the X, assuming that the anticlockwise equal to 0, becomes minus m, which is the real moment, not minus 30. So therefore, our m equals minus 30 kilonewton. Now, by using the unit load method, which we are given here, by using the formula here, which we are given here, which is the vertical displacement equals the integral of the product of the virtual load case multiplied by the real load case moment over the stiffness, which is EI, with our integral ranging from 0 to 2. Don't let us forget the length of our beam is from 0 to 2. So therefore, by pulling out our stiffness out of the integral, we have 1 over EI with our integral from 0 to 2 with the product of the virtual moment with the real moment. So therefore, we have 1000. Don't let us forget our moment is calculated in kilonewton per meter. So we pull out our 1000 over 8 times 10 raised to the power 5 with the integral of negative 30 times product of 2 minus x dx. So therefore, by integrating our part here, we have 10 raised to the power 3 over 8 times 10 raised to the power 5 into integral of 2 to 0 30x minus x. So therefore, by slotting the 2 to 0 input, we have our displacement to be negative 0.075 meter. So therefore, our vertical displacement is going to be negative 75 millimeter calculated. Thank you very much.